We have question 3. Find the y, the x, this following equations. So we're going to start with the first one, which is this. Yeah, if you check the first one, you realize that it looks strange, okay? And we are not informed the method to take, okay? So if you look at it critically, you realize that this is what? This is complicated function, okay? And in such case, we use logarithmic differentiation. Take the lane of both sides. If you are using logarithm, the first thing you do is what? Take the lane of the two sides of the equation. So that will be this ln y equal to what? Lane of this function. So, and if you do that, according to the rules of logarithm, this power will come to the front. So we have, so that's what we have now. Then the next thing to do now, we're going to differentiate this, since we are looking for the y dx. Differentiate this respect to x. Y is a function of itself, so differentiate that respect to that function. And finally, differentiate. So when you are doing implicit differentiation, you differentiate this respect to that function, and then you put your the y dx by the side. We're going to apply product rule because we have two functions. We have this one and we have this one. So I'm going to take this first one, constant. I'm going to differentiate this one. So times 1 over what? X plus 1. 1 over the inner function times derivative of that inner function, which is what? 1. Then plus, you've already differentiated this one in the first case. So I'm going to take it constant. I will now differentiate this one. So the differentiation of this one, I'm going to do it somewhere here. Dx of this function. In this one, you're going to differentiate this one. I mean the outer function, which is what? Minus what? Sine of the inner function. And then times derivative, differential coefficient of the composite function of the inner function. So I'm going to plug it here. So that's what we have there. Then we can remove this one from here by multiplying through by y. So your dy dx is going to be what? Y. And I have value for my y. This is my y. Okay. So there's no need of writing y. So I'll just cancel that. So open the big brackets. So then you just write the old expression here. So plus times minus, that's minus. So that's that on question 1. Yeah, the B parts involve two different variables, x and what? And y. In that case, that call for implicit differentiation. So differentiate implicitly respect to x. So look at this this one. You know, when you differentiate e function, it's going to give you that function. Times, you now have here, you have two functions there. So I'm going to differentiate this one. So that will give me 2x. I'm taking this one constant. Then plus, because this one involves product rule. I'm going to take this s squared as a constant and differentiate the y. Respect to what? Respect to x. That'll be the y dx. So I'm through with that. Then if you differentiate cotangents, it's going to give you minus cosec squared y equal to what? Equal to 0. These are just applications of what? Direct table. Okay, most standard exam, they will give you the list of your differentiations just for you to apply your table given to you in the exam. So derivative of this one is what? This. So then the next thing, we skip something here. We are differentiating respect to y. So it's going to be what? It's going to be the y, the x attached to it, because it's a function of y. When you are doing implicit differentiation, it's going to be d the y of that function, okay, and then the y dx. So that's how to do your implicit differentiation, okay. So then the next thing to do now is to collate, bring together your dy. So it's going to be this one. I'm going to open this one, okay, dy dx. Open your brackets. So this will be this one times this one. So I'm having this one, x squared times this function. There's also the y here. So minus csc squared. Then you close the brackets. Then you move this one to the other side, and that will be what? Equal to negative this function. That's what we have now. On the final note on this question, just make the y dx as a subject, and then you have what? You have this. So that's that on these on the B parts. This third aspect, I'll make video on that fundamental theorem of calculus. We are not going to spend time here. We're going to go straight to the solution because we are under exam tension. We're not going to waste time. So for more in-depth understanding, please check my video on fundamental theorems of calculus. Okay, so what we're going to do here is very straightforward. We are looking for the y, the x of this function. So this is your y. So what they are telling you is just for you to what? To find d dx of what? Of this function. So this is our question. That's our y. And don't forget, all this one, they are equal to, they're all y. This is y equal to this. This is also y equal to this. Just so this is your y. This function is your y. So d dx of this function. So it's very straightforward. What we are doing is simple. We are finding derivative of integral. It has the upper function and lower function. The lower function is a constant. So it's going to be, you substitute, make substitution, 1 plus. Anyway, since it's a function of t, anyway you see t, put this value there. So that's what? That's a log 10 x to the power 4. Okay. Then you square that. You square that. And then times the derivative of that function. And we're supposed to do the lower limits, but we are not going to do that because it's a constant. We're going to skip that because the moment you differentiate that, it's going to what? It's going to cancel. So we don't need to do that. Okay, you don't need to substitute as we did for the upper limits. What I mean is just minus. Do your substitution again. 1 plus what? 1 plus. Anywhere you see t, put it there. So that's what? That's 3 square, and then d the what? D the x of what? Of 3. Okay, so this one we don't need that. Once the lower limit is an integer, okay, don't bother to what? You don't substitute for that. Okay, so we don't need that. So the answer will just be this. Okay, the derivative of this one is going to be what? It's going to be 1 over the function here, and then ln of the base, and then times derivative of the inner function. That's 4x cubed, and that finish the question. For more in-depth understanding on this aspect, please check the video on fundamental theorem of calculus. Fundamental theorem for calculus. I think it's at 5.3. So check that. Explain, and we have a lot of questions to buttress that. The D part, we have y equal to. So this is what we have, and we'll be instructed to use logarithmic differentiation. So in that case now, as you all know, when you are doing logarithmic differentiation, the first thing to do is to take the ln of both sides. So it's going to be ln of this equal to what? Ln of your function. In that case now, do the algebra by applying the laws of logarithm. So this is a product. We're going to have ln plus ln of sine x, then minus ln. No, for the division, for the denominator, that will be minus of this function. Apply your logarithm, and ln of e is what? Is equal to 1. So we just have this one alone in this place, plus this. So that's what we have, plus this and then minus this. Then we can now differentiate now implicitly respect to x with respect to x. So this will be 1 over y dx. This one, arctan. So this will be chain rule. It's going to be, you're going to differentiate the outer function first. That will be sec square the inner function, and then times the derivative of the inner function. That's a 5x4. Then plus this one will be what? 1 over sine x, and then derivative of the inner function. That's a cos x. Then this one minus is going to be 1 over this one. Okay, and then times derivative of the composite function. The composite function, the inner function is this. So it's going to be half, okay, because this one is equal to x plus 1 to power what? To power half. So that will be half into bracket x4 plus 1. Then this power minus 1, so minus half times derivative of the inner function, that's a 4x3 using chain rule. So this will be 1 over 2 square root of what? x4 plus 1 times 4s cubed. Remove this y from here, multiply 2 by y. So we have the y, the x is equal to your y, which is your question, which is this. So that's your y. Then open a big bracket and put all this inside that bracket. This one will give you cot. That's a cot x. Okay. And then this one, this is radical. This is radical. So it's going to cancel. So I'm going to have minus 4s cubed all over. Even these two here 1, 2 here 2. So I'm going to have 2 on the top here. I'm going to have 2 here, and I'm having x4, x to the power 4 plus 1. Okay, and then you close the brackets, and that is that on this question. To advance this channel, click on the watermarks on this video and subscribe. Click on like button and begin to put your comment through. Type your comment, say something, and I promise you I'm going to respond to your question as soon as possible. Okay, finally share the links of this video on all your social media platforms. Thank you for doing that.